Algebra II, 3.7c. Determine if two lines are perpendicular. Now, if you haven't seen 3.7a or 3.7b, you might get confused, and the links to those videos are in this video's description, so you can just click on them real quick, all right? If two lines meet at right angles, they're perpendicular. If one line has slope m, the second line that is perpendicular will have slope negative 1 over m. That means the second line has a slope that's a negative reciprocal of the first line. So if the first line has a slope that is a 3, the second line's slope will be a negative 1/3. It's a negative reciprocal. If the first slope is a negative 3 over 2, then the second slope will be 2/3. See, it became positive. It's the opposite, and it's the reciprocal. So I have a theorem for you. Two non-vertical lines are perpendicular if and only if the products of their slope is a negative 1. So for that 3 and negative 1/3, when we multiply them together, we get a negative 3/3. That equals a negative 1. It's got the same numerator and denominator. And the negative 3/2 and 2/3, when we multiply them together, we get a negative 6/6. Well, same numerator and denominator. It's a negative 1. So are the graphs of these lines perpendicular? So we've got 5y equals 4x plus 10 and 4y equals negative 5x plus 4. We find the slope-intercept equation by solving for y, and we can divide each of this equation's terms by the 5, by that coefficient, and we could multiply by the reciprocal 1/5 if we wanted to, but there's no fractions here, so we've determined that it's easier to just divide. It's the same thing. And we get 1y equals 4/5 x plus 2. Same thing on this side. We can divide by 4 for each term, and we get y equals negative 5/4 x plus 1. We find the product of the two slopes. We've got a 4/5 and a negative 5/4. We multiply them together and get negative 20/20. That's a negative 1. So yeah, it's perpendicular. The product of the two slopes is a negative 1. When we graph them, this becomes the first one, and that's the second one, and they're perpendicular. And look at the rise. It's got a 4 and a run of 5, and this one's got a rise of a negative 5. It's going down, and a run of 4. Remember, if it rises to the right, it's got a positive slope, and if the line falls to the right, it's got a negative slope. All right? So I've got the proof of the perpendicular line theorem. So consider the line AB, that pink line with the slope A over B. All right? So look at this pink line right here, okay? Imagine rotating the entire figure 90 degrees to get a line perpendicular to AB. So what if we took this line and just flipped it that way, okay? So I have a clear overlay. If we flipped it that way, do you see what's happening with the A and the B on the pink lines? Okay? This is how it was. See how the B is going horizontal and the A is going vertical? Up. Now look, if I rotate this whole thing this way, doesn't it look just like the B line? The blue line, I'm sorry. Doesn't it look like the blue line here? The orange is going vertical and the green is going horizontal. See how the A and the B swapped places when we flipped it? So for the new line, the roles of A and B are interchanged. They're swapped. But A is now negative. So the slope of the new line is negative B over A. See? Like this one. See? When we multiply these slopes, the A over the B times the negative B over A, we get a negative AB over AB. Remember, we put them in alphabetical order. Well, same numerator and denominator, that's a negative 1. The lines will be perpendicular under these conditions. So if we were to look at it this way, the blue line has a negative 3 rise. See, it's going down. It's falling to the right. And the run is a 3. 1, 2, 3. See it? And negative 3/3 is negative 1. And look at this one. We've got, for the pink one, let me remove this. We've got a rise of a positive 3 and a run of a 3. And that's a 1. When we multiply the negative 1 times the 1, we get a negative 1. So what we do is we put the equations in slope-intercept form. We multiply the slopes to get a product of a negative 1. If the product equals negative 1, then we know the lines are perpendicular. Okay? Our next video is 3.7D. We're going to talk about equations of perpendicular lines. I'm going to add this video to my Algebra II playlist, so you can go there. The link is in this description, and you can use it to study. And there's also a link for the Algebra I, Chapter 7, Graphs and Linear Equations playlist to help you out. Okay? And remember, on Android, all you have to do is hit that little triangle, and it'll open up the description. Okay? If you're on your cell phone. All right? Okay. We're going to talk about equations of perpendicular lines. I hope I explained this well, and I'll see you next video. Have a great day. Bye.